Yes.
Thumbs up.
All right. So welcome to part 2 of the Docker workshop. This one we're going to do a little bit of a deeper dive into some of the composition aspects of Docker, ways that we can get containers collaborating together and to perform more complex behaviors. Again, I'm going to give you the caveat I gave you last time. I'm skipping over a lot of detail because we don't have time for a lot of detail. And frankly, once you get mired into the detail, it's not really great for presentation, and it's kind of boring for everybody to look at a bunch of dense code typing stuff. So I'm going to keep it still at a fairly high level, even though the concepts will be kind of a bit more complicated than we did before. So I've moved the workshop into 2 parts documents now. So if you go over to the part 2 MD instead of the README, that's where we have the new stuff. All right. So as we started talking about last time, containers. One way to collaborate with containers is to just mount volumes between containers so that they're sharing data. That's kind of the most basic form, other than extending containers by changing their content. The most basic way to get them working together, 2 containers working together, without changing their images, is just to have them share some content together. I'm going to introduce one here where we're also going to have containers that collaborate with each other by making a network connection to one another. So starting with this here, we want to create a new directory and make it your current directory, and then make a new directory called data inside of it. I'm going to go ahead and type along with myself here. Type along. Okay. I'm going to make a directory called data. And then inside that data directory, we should put an HTML file.
Do you mind making that a little tiny bit bigger for me?
Make things
We can make it much bigger.
Absolutely.
Is this inside the Git project?
Yeah.
Or a different directory?
Inside of no, do this in a separate directory, a brand new clear directory. Don't do anything in the Git project.
Gotcha.
How's that? Is that better?
I meant the command line, actually.
I don't know how to do that. Does anybody know how to do that?
Control.
Yeah, it's
Command
like
plus.
Command
Try
plus
Command
or
plus.
Command Shift
Yeah,
plus. One of those
Okay,
two.
cool. How's that?
Okay.
I'll get this one down again, and then we'll move this one up again. I can make it wider, and that'll be helpful.
Please.
And then we'll plus it up.
Maybe one more size up.
Is that better?
Yeah, it gets better every time. So yes.
And hopefully you're typing along, and you'll see most of the stuff on your own screen. So. Okay, you're going to make an index HTML file, put whatever you want in it. I have a sample here if you just want to cut and paste it. But you can feel free to make it your own. I'm going to just keep kind of moving forward, and just hold me back if I'm way far ahead of anybody that needs me to stop. Okay. So I have 3 commands that are written after that, and we have a Docker create command. This is going to create a data volume that includes the data the index file that you just made. You can type it if you're a typer. Cut and paste it if not. I've typed it many times, so I'm just going to cut and paste it. But nothing wrong with getting the manual feel for how these things flow by typing it. And we did this last time. We created a data volume. In this case, we're pulling some data.
Your body type wrong.
What's that?
Body type, the first one.
Yeah, I'm sure it is. Yeah, you're right. It's not going to impact this
Oh,
thing.
okay, never mind.
But I will edit that. So I just created a data volume. We did this last time. The only difference we did is that this time, instead of writing a Docker file or whatever to make the data file, I'm just taking a shortcut and saying take some content off of my hard drive and put that in the volume. The second thing we want to do is just run. We're going to run Nginx, and we're going to run Nginx with this content that we just made mounted in its user share Nginx HTML directory. So that's the second command there, docker run. -d means demonize it or detach it from the terminal. And we should have another one. So now if we do a Docker PS, we'll see that we have that up and running. Oh, I have a bunch of stuff. I should probably get rid of some of these. Oh, yeah. I'm going to clear my stuff out real quick. So now I have an Nginx running, and now I can also run this last thing. Just run a curl command inside of a Docker container, and that should go ahead and fetch our content and display it to the screen.
Yeah, I got couldn't resolve host empty string.
Sorry about that.
Yeah.
Resolve host empty string. All right, let's try this again. Okay, we're going to Docker create.
Don't copy the period. That's what will give you the cannot resolve host.
Okay.
But yeah, it's not picking up the index HTML file.
And that is so interesting.
Well,
Systems.
No, I'm still going to just Nginx.
Greg,
Yeah.
I noticed that we created the volume, but we didn't attach the volume to any of the containers.
We did not. That is, you're absolutely right. I must have left that out. And here, you're absolutely right. So in number 2, so go ahead and stop the Docker and Docker PS. Go ahead and stop the Nginx service 1. Docker stop service 1. And that's what we need there. You're absolutely right, MJ. We need volumes from.
So do we have to remove the container first before we spin it up again with the data volume, or is there a way to restart it but attach the data volume to it?
So we would, oh right, because we gave it a name, you're right. So Docker remove service 1. Okay. Because we named it, like we did show last time, you can't have something more than one container with the same name. So now we're going to run that service name again, service 1 again, but this time we're going to take our volumes from.
Do we have to recreate? No.
We don't have to recreate the volume, but we do have to.
No, yeah, the volume's good.
You have to redo line 2, but first what you have to do is stop at the service 1,
Yeah.
and then you remove it, and
Yeah.
then now just re-execute line 2, but be sure to add the volume as part of the command.
So you want to add the volumes from data 1 in that number 2 command before the Nginx, after name service 1 or.
And then rerun.
So
Can you be bigger?
well, it's just
Well,
it's low and to the
Is that
right.
right?
It's hard to see. That's all.
but now I get 4 3
It's
forbidden.
fine.
Is that expected?
Say again.
I get 4 3 forbidden now instead of using Nginx config.
From what? Data one.
From data 1.
Did you put an index file in that data
Line
directory?
three.
I believe so. Let me make sure I got the right.
That's what that would be the path that you need.
Docker.
Is there a place we can navigate to test if this is working?
Right there. So that's the last command right there, number 3. We'll show you.
Oh, you just run that command?
Mhm.
Or it shares it.
Sorry.
403 forbidden. Yeah.
Too cool.
So if you got forbidden, it means you might not have a data directory with the index HTML in it.
I pointed it correctly. No. What's that?
Let me take a look at these one at a time. So
Do an LS.
Here's the.
oh, you have nothing in data.
I made something.
Where'd it go?
Oh, I didn't.
Oh,
put it in.
yeah, you're supposed to be in data.
So yeah, if
Put it
you
in
made an
place.
index file and didn't put it in the data directory, that will cause that
That's
problem that
silly.
people say.
I did. think.
See what you got.
Stuff happens. I see
I
it.
think.
The curl.
Yep, there we go. It works now.
Yeah, it's in the wrong
Somehow I made my
True.
things
spot.
somehow I made my
Do I have to
inside data
recreate
have
something
that's
after I move it?
Yes.
So you do.
So it's line 1, I have to like do line 1
Yeah,
again?
so
Which
first
means I gotta
remove it.
nuke up data, I gotta nuke data 1 and redo this again.
So Docker RM data
Oh.
one.
For not
Dash
found.
Docker,
Um,
dash
Dash
B,
B.
data 1.
you have to run it from
Okay,
outside.
and then I need
Oh,
to move
okay.
index into, oh, I see the problem, data.
Actually, because it's live, you probably could just move it up. But that's
Okay, so I am in data, it's just, okay, so now I know, yeah, that's the problem. Now, if I
How do
true
you
this,
see it?
I've got
Like,
the right thing. So
Oh.
I'm getting-
now if I rerun all these, I should be good.
okay. How are you doing, Netta? You good?
I think.
Mary's getting 404.
you're seeing it.
What's
Oh,
that?
I
Mary's
see.
getting
We're supposed to see.
404.
Okay.
Did you run all these things?
Just your machine.
Okay. I did, but maybe
Lots
from
of
the wrong
comments on it, but
directory.
Trying to
No,
click
no.
break, what's in the
I'm glad I
directory?
got it. It's running.
That's all right.
Does that look right?
That's what I get for sitting in the back.
I'm sitting in the back too.
Mm-hmm. But when you do the curl command, what
I'm
happens?
actually cheating. I'm actually looking at his. I pulled up his notes.
It's
Yeah,
curling.
the notes are good.
And then
I pulled up his notes just in
I
case.
have that too.
Mm-hmm. And you did the service that you created the service with. You created the volume,
Okay.
the data volume with that data directory.
I think so. Let me try that.
Oh,
Is this one? Yeah.
question
The first one.
Oh, okay. Not after I delete it. Okay, so
Yeah.
that's probably it.
Do you have a data file or a data folder?
Yes.
All right. Should we pause for a little bit longer?
Kids. Did you figure all these? Okay. No, it's fine. It's fine. It's fine. It's okay. Don't sweat.
Can you explain the last line? What exactly?
Okay. Yeah, that's what we'll do. Let's get the last line here. Okay. So what happened in this? We just did. We created a volume like we were just going through that had our data in it. Then we started Nginx with the data from that volume mounted in its web root. Then we, after we ran Nginx, we then ran a container that's only job is to have a curl command in it, and we ran that against a URL called HTTP webs, which we defined in this link service 1 and call it webs command or option. So when we said link service 1 webs, what we did was we said make a network connection to this container and give it the host name webs from anything inside of the container. Then what we did here is we ran curl against a URL called HTTP webs. Webs is a host name that's now known to be a virtual network host that is tied to this container. This container we in line 2. So all that typing and everything is really a bummer. And you can see it's error prone, there's little things that are wrong. So what we have is this thing called Docker Compose, which is another part of the toolbox. And rather than typing all this stuff into a shell, what we can do is create a composition that does all that for us. So change to the directory that it has. It's called part 2-a inside of the workshop project. Okay. And from here, just type Docker Compose. It's one command. It has a dash in it, Docker dash compose. And you're going to use the run command, run subcommand, and you're going to run the curl service. So Docker Compose, run curl. We'll do some spinning, but it'll eventually get you an HTML file or an HTML output. Did that work better than the first set of commands?
Run curl. Cool.
That work for everybody?
Sweet.
Are you having trouble? Is yours not working?
It's not working. That's okay.
Let's fix you.
No.
We have time. We have plenty of time.
It's fine.
We want everybody to work.
Got it. You got it.
Yeah.
I just have me like
This the side of the table is killing me.
Alright, so you have to remove the service
Make it a
one.
contrast on that.
I'm sorry, this is
And then what does your volume look like? Do Docker PS. Docker
I'm too excited.
Do it through head. Do it through head. Alright, so what we got is one. And if you were to alright. So let's start to do what I want. You can do Docker. Docker PS.
Do it up.
Dash QA.
Feel better now.
Pipe it through XR. XRs. Docker RM dash V. Now just do PS.
Damn it, this is kind of glitchy,
No
Joe.
containers.
Oh, it is.
Yeah.
It's not as good as
Now you
It's
should
just
be
the
Xminet.
window manager.
First
like,
one.
Not quite Xminet.
Like, why are you doing this? Why? I think. I understand.
Now we have that, and you're in that. You made that data directory with
That
the
is
index HTML,
nice.
so I'm assuming that's cool, right? Yeah, there we go.
It's really
Run.
Oh, we need the volume from it.
Right, that's right. So add that.
It's certainly not T-Box.
I use Xminet too. One's for Windows, one's for.
Cool. Now we've got
But you're right.
no, let's do it.
Yeah.
No, I think they're orthogonal.
Click again.
Here you go.
That works perfect.
Cool.
Thanks.
Just had to nuke it, that's all. All right, so we're all in the same spot here. So let's go look at how this happened. Down here, I have what's called a compose configuration file. They're YAML files, and the heart of a compose file is that it lists a bunch of services. And services are roughly containers. And you can see I have a data container that corresponds to. We're pretty much doing the exact same thing we did before, but we're just setting it up to run in a repeatable way. We set up a data container that builds from a data file, builds a container from a data context. If you look at the source code, you can see data just contains a Docker file and that index HTML. We launch Nginx with volume from that data volume, and then we run the curl image with a link to the Nginx website, and we use website as the URL. Just to let you know, links is not the linking mechanism in Docker is actually deprecated. In later examples, I'll show you. We'll be getting rid of the links, but it's just a simple way to visualize what's happening, which is why I left it in this particular case. But links just says here, use this service, use this container that we named up here, call it this as a host name inside, and then we can use curl to get to it. So that's pretty simple. You can actually do Docker, if you do Docker compose down -v -rmi local, that will just clean up everything we just did. So that's nice also that you don't have to do manual cleanup. It'll actually tear down everything you did, get rid of all the volume, all the images it made. That's a nice way to just be done and not have anything as if you had never done this to begin with. You can also just you can do a different if you don't use local, use a different. I think it's I forget what the other one is, but you can get rid of all the containers, even the ones that downloaded. I mean, all the images, even the ones that downloaded. In this case, we're leaving the ones that downloaded, just getting rid of the ones that built. All right, so all this is leading up to something that we can make a more complicated kind of configuration. So let's start with changing our directory to part 2b.
Do we have to stop the previously running container?
So that should have happened already. Oh, the very first one we did? Yeah, you can stop that first one. I think
Oh, should we have everything stopped right now?
It does say it at the top.
I think it says it, I just forgot to say it. Yeah. So you can do Docker stop service 1 and then clean that one up with Docker RMV data 1 service 1. That's for the first one. For the second one, all you have to do is do this Docker compose down and it'll take care of it.
It's done.
So if we go into the part 2b directory, I didn't show the Docker file in here because it's a little longer, But you can go to it, it's in the source code, or you can just cat it if you want to look at it. But we'll look at it after we get this thing running. So let's start by just running the application. So while we're in this directory, we want to use a Docker Compose build. That'll build all of the parts. Now the nice thing about Docker Compose is no matter what subdirectory you're in of a project that has a Docker Compose YAML file, it will build as if you're in that root directory. So you can be working in a different directory, type Docker Compose command, and it'll go up the directory tree, find the configuration, and run it from there, which is pretty convenient while you're developing.
So this uses npm inside here?
The application that I built for the sample does. So we're using a node. There's 2 node-based services, a Redis data store, and an Nginx-based load balancer are what are in this application. So let's go ahead and go over to the configuration, which is we can do that from
Wi-Fi's down pretty slow, so we can do waiting.
Okay.
Yeah.
I'm going to move over to the. Oops, I'm going to move over to that directory here, so we'll just look at the source of the nice. So here's some of the components. Let's look over at the Docker Compose. So while yours is building, let's take a look at what's happening. What we have here. We have a counter application. This is a little microservice. We have a message of the day application. That's another little microservice. Both of these are Node web services. Interesting about these is that they both actually serve their content through the root of their root path. So they don't have, in this case, they don't have any distinguishing paths. It just things come into the root path and they serve them up. We have a data store that is for both of those things. They both use this Redis backend. And then we also have a load balancer, which is Nginx. Nginx has a couple of things we can do with it in this file. One of them is we expose the port 80 and map the Nginx containers 80 to it so that we can get to it from the outside world. We also grab our configuration from this balancer configuration container, which is right here, and that's built in this subdirectory. And let's go through this real quick. Let's just go to the actual apps themselves. So the Nginx configuration is pretty simple. It takes everything in the HTML directory and puts it here. It takes everything in the config directory and puts it here. And then that makes and uses this volume command to make them mountable into the Nginx container when we do that. The other interesting things in here are the Redis configuration is actually empty. We had no need for Redis configuration, but I put it there just to conceptually be there. This is where you put any kind of security you needed in there or whatever. But right now we have a wide open Redis database. In our 2 apps, these now are a little more interesting. So let's take the counter application. It's got a Docker file. It's based on this Node Argon, which is the LTS version of Node in Docker. I think it's Docker 4 point something or other. Sorry, Node 4 point something or other. It makes a directory for the app, and it takes our package JSON, puts it in there, runs npm install. This is all part of building the container. So when you were building it, you saw the npm stuff flying by, and that was this part, building it. And then it also says that our port's going to be 8080, and it also says here that in order to start this container, we just run npm start. So, and then the counter application is...
Is that command the thing you're only allowed to have one of?
Command, you can have one, right, there's a default command. You can have as many commands as you want, but there's a default command. If I don't supply a command, that's what it will run. So server.js is just a simple server that uses Redis actually uses something I've never used before, which is Redis PubSub, which is kind of cool. So it was also an opportunity to just try something new. But as you can see, the get and the post only occur at the root paths here. And then they push their data to Redis, and then post actually publishes it to a queue, a Redis queue. The message of the day is largely the same application, just with a little bit more complexity, but same kind of thing using the backend. So if you look at here how this is configured though, one of the things that could be externalized if you needed to, but you don't necessarily need to. And I find this pattern is actually pretty common now in when I'm looking at this kind of deployment. If you look at the, hang on, let's go back to the counter app. This actually gets, it actually uses a host name store. That's hardwired in here. You could make it so you injected it from the outside as an environment variable or anything you wanted to do. That's not, because in a continuous deployment world, you're not, the only thing you have to change is this and then redeploy and it should work. So it's pretty common to just have it, give it a logical name and then use the outside configuration here to actually use that name, and that's what we do here. We call it store. And because we call it store here, and because we're not using links, that's what actually shows up as the host name to anything that's using it. So we're now using what's called an overlay network instead of links. And the overlay network, you can actually make more than one network and have them, we'll get into that a little bit, but on that network, these net names are going to just correspond. You can override that name with another directive called container name or something like that, but if you don't do anything, this is the name. So our counter service is going to be called counter to the load balancer. Our message of the day service is going to be called message of the day to the load balancer. And our Redis backend is going to be called store to the two microservices. If we quickly look at the Nginx config real quick. In the config, we just have one little public configuration. We do two things in this. One thing, I'm also serving the static content, but you could think of it, there could be another way to serve static content. It's just as easy and it didn't have anything to break it out. So this is serving the static content, but it's also doing reverse proxy. And there's our names. We have a counter, and we have message of the day. And notice that we're doing the mapping here. This is where we're doing the path mapping. So this passes counter through to the root of this service, and this passes message of the day traffic to the root of this service. All right, so let's bring it up, since we've done a lot of talking about it. Let's go to all right, so Docker compose up -d. That's all you need to type from that directory, part 2b. -d again is just to detach it from your terminal. So now when we look at Docker PS, we see a whole lot of stuff.
Mm-hmm.
And that's all the things we just made. And I think I still have Docker service.
Okay.
Yeah.
Okay.
But anyway, I don't care if it's out. So interesting thing here is that there's one container, the Nginx container that's called port 2p balancer 1. That one actually exposes to the host, to the container host itself on port 80. So we can actually go to our browser now and type in whatever this host number is. So right now, if you want to see what your host ID is, you can just use a Docker machine. Unless you're on Linux, you can just use localhost. Docker machine, or IP default if you're using the default name. And that'll give you your IP address. You should be able to just open up a browser window, put it in there, and see the lovely application.
Yeah.
So this application hits the services. You can increase the counter by hitting increment count. You can update the message of the day by typing new message and update the message. If I clone this up to another, let's just put this in another, actually if I make this in a window. I don't know. Let's just, but you can see it's the same. If I can update this one, increment it, and it shows up on this one as well. And if I have separate windows, or if we're all attached to it at the same time, because it's using web scale technology, it'll go super fast. So that's it. That's the demo application. Is everybody running it? Is it all working on everybody's machines?
Not working.
What's happening on the?
I'm not sure. I did Docker compose up -d and a bunch of stuff happened. I seemed happy.
Mm-hmm.
When I do
the right address.
when I do Docker PS, I only see Redis.
Oh, so not all your containers started. Try doing docker up-d again. So there is a timing issue where if Redis is not ready, it doesn't usually happen when you do this the first time.
Docker compose.
Yeah, docker compose up-d, sorry. If Redis is not ready, it's not waiting for it, and it's just crashing.
So how is the message getting from one tab to the other when I hit increment on one? How's the other seeing it?
I'm using the services are taking advantage of Redis's pub sub architecture.
Okay.
So when it stores a data value, it also pushes it to a channel, and all of the this is all doing long polling, so it's all just waiting for the channel. So each channel is just waiting for it tells you it's telling it what number it has, and then it waits until that number, and it'll sit there and long poll until that number changes.
How did you say to get the IP?
Okay.
So that'd be Docker machine.
Docker machine will work on mine because I'm using a different.
You should have Docker machine. You have to have Docker machine.
Okay.
Docker machine IP default.
The host does not exist default.
Do Docker machine ls.
I have none. That's good. The rest of this process still worked.
Cool. Okay, so I don't know how to help you in your case
All right.
yet. Sorry about that.
Yeah, so it's interesting. I actually managed to get them out of sync because I clicked like really quick on this one, and it saw the first one message, but it didn't see the second one.
Yeah, I'm not claiming this is a great application. I'm just
I was just curious how the message was being transferred.
I know, I heard web scale. Are you sure?
All I have to do is go to
Greg? 'Cause
I just went to
pretty
localhost and the
endorsing.
browser worked fine.
What's that?
I just went to localhost in the browser with no port number.
So it is. So it's virtualizing it and it's giving you a network. Okay, so that's how that's working in that new thing. Okay, you may not be able to get through the Docker swarm part of what we're doing, but we'll see. So cool. We got it to work. Got it to not work. Thank you, Sean.
And,
But anyway, that's not the.
So Sean, you broke it?
I'm sure there's all kinds of race conditions and problems with my application. I was jokingly saying web scale because I used.
no, I managed to get these messages out of sync.
Oh, really?
For a time.
Cool.
I have the recording to prove it.
So is engineering.
Docker compose.
But that's just a bug.
So anyway,
It's scaling on something.
but don't worry about the application. It's really done. Okay. Okay, so let's move on to the next part. If that's working for everybody, the next part is to see how we can change some things in our application. So back to the here. Okay, so one of the things that we could change is maybe somebody comes to us and says, "Yeah, that's great, but you know your services are running on the same network as your load balancer, and that's running on the same network as your database. And if somebody compromises Nginx, they're getting straight into your database, and boy, that'd be terrible." So one thing we can do is to make those people happy is we can put our database on a separate network from our load balancer and have our services be able to talk to both, but not be able to. But each load balancer can't talk to database can't talk to load balancer. So this is all just leading up to me showing you an interesting and cool feature of Docker Compose, which is the Docker Compose override. So in Docker Compose, you can create a file called Docker Compose override YAML, and everything in there will be an override of what's in your main Docker Compose YAML file. And I put that in gitignore usually because it's a great tool while you're developing. You can put things into your Docker Compose override, make changes, but they don't get committed. Or if you're trying to like isolate some part of your application and you want to slightly configure it differently while you're working on it, you can do that in override, and that won't become part of your source code. So go ahead and make a new, in the same directory, in the part2b directory, make a file called dockercompose.override YAML, or YAML, and put this content into it.
Vim did not like that paste.
It's auto indent.
Turn off auto indent.
Just do set paste.
Set paste.
Full set paste and then do it.
Is it one word set paste?
So which ones do we want to stop? Which processes do we want to stop?
All right, so in this case, don't stop any processes. Just make this file, and then use docker compose down-v and then docker compose up-d. There's also a restart you can do in Docker Compose. Restart, though, will not build the new networks. So that's a restart only restart services in the existing network configuration. In order to get a new network configuration, you've got to bring it down and bring it back up.
Yeah, so I have to up-d twice each time you have to have that done.
So yeah, it sounds like there's a race. Yeah. So we're not waiting on the Redis to be ready. That would be a feature you could add to your container to have it as it's starting up, to have it recover gracefully from back and not being there. This being
Just for anybody else who's done the same thing.
yeah, and you will have the same issue when we start doing the Docker Swarm. It happens every time we Docker Swarm. It's the only reason I know that. So if you look at my output here, we ended up creating a network called default, which we're not actually using. We ended up, that always gets created. We ended up creating one called service and one called database. If we do Docker network ls, you can see a list of all the networks that we have running in Docker, including the ones we just made. I'm sure there's like a really detailed command you could use to find it. I can't find a Docker command that tells us what containers are attached to what networks. But I went into these containers while they were running, and I was able to confirm that I couldn't reach like the database from the load balancer. Feel free to get in and do that if you want.
Whoa.
Some of these commands list a lot of JSON output.
Yeah.
All right. Is everybody past this part? We on the part where we've made our changes, our network changes, and brought everything back up, and you can verify that the application still works, probably.
Mm-hmm.
Oh, because I brought it down, it started my database over again. So my count is the same, but let's get the message.
I tried so hard. It just clicks.
Oh, there we go.
All right. So the next topic to discuss is the topic of schedule. So now we have all this composition stuff we can do, and you can make very complex networks, and you can do a lot of complex things. You can actually scale these from within Docker Compose. I could say Docker Compose scale, one of these services, and I would get multiple copies of this service. Now it doesn't do much good being on one machine, but that's where we're getting to right now. So the idea is that once you have this composition capability, the next step is how can we take a whole cluster full of hosts and have something just assign Docker containers to those hosts without me, making too much of a fuss about it. And that's the role of scheduling. And there are a lot of schedulers. Docker Swarm is kind of the one that is built into Docker Compose and built into Docker Machine. There's others like Kubernetes. AWS has their own called ECS. There are a lot of them out there, and their whole purpose is to maintain some set of rules that lets you launch into a cluster of VMs or a cluster of physical hardware, and have those containers put where you want to. So you can make rules like I put some examples here. Run this container on any available host. It's a simple rule. Just run this container to its termination on some host that you find suitable to run it on.
Why do the other third-party schedulers exist?
Different feature sets. I mean, more or less complex feature sets. Docker Swarm is fairly basic. It doesn't have a tremendous feature. It's not. Some people just distinguish themselves by features. AWS does their own because they don't make you run your own scheduler. They run a scheduler of their own, and you can use any host you want that runs their daemon on it to be it. And then Kubernetes is the one that's the basis of the JBoss, whatever that their new POS thing is. Kubernetes is one of the older ones. It's been around for quite a while, and I think it might even predate Swarm. So it might have been one of those things that we saw it, and then Swarm kind of caught up with it. So But there are a bunch, and you can use them. And so other examples of rules are like, keep 3 containers from this image running at all times on whatever host you can put them on, but just you have to be on different hosts. So that might be a way to have some redundancy. But there's all kinds of rules, like affinity rules. Run this container on the same host that you run this container whenever you run it, or whatever. And all of them have all of the different offerings have different ways of configuring this and different feature sets, different kinds of scheduling rules that they offer, and that's how they distinguish themselves. But we're going to go through and try this on Docker Swarm, which is a little bit scary because trying to run multiple virtual machines on the Mac I found to be not things locked up occasionally. So we may lock up. If you're all using Linux, if any of you out there using Linux, you should be able to run the virtual machines using VirtualBox as well. I don't know how it's going to work for you, Michael, so you should just try to play along and see if you can get it to work in what you're doing. Because you have Docker machine, but I don't know that your Docker machine can do this, but we'll see. So, and one thing and you might be able to run the VirtualBox Docker machine as well, and it's probably possible that you can run a virtual machine in VirtualBox even though you have that facility. One of the things I found was helpful is I stopped my default Docker machine right to begin with. So if you do Docker machine ls, you get a list of your machines. If you have one called default, just Docker machine stop it, or whatever yours is named, Docker machine stop that one. We'll bring it back up later when we're done, but that just helps by not having extra virtual machines. The other thing I did is for all these virtual machines, I reduced their memory down to half a gig from the gigabyte that's the default. All right, so let's just start. One of the things that's needed and just keep in mind, there's a couple things. Actually, I'm going to back up a second. Docker 1.12 just came out a month or so ago. Docker 1.12 actually changes a lot of things. And so the documentation, when you go on it right now, some of it is compatible with 1.12, some of it's not. If you work through some of their swarm documentation, it's actually simpler than this because it takes advantage of some Docker 1.12 features. But it doesn't work on anything older than 1.12. What I found here was something that I think works on most, on what I think works on the older ones, and we'll see if it works on 1.12. It should still work on 1.12. That's what the claim is. But some of these things you need, like an external key store, which is our first step here, are not needed. From what I understand, are not needed under Docker 1.12 Swarm. That they have their own internal key store. That they've always had an internal key store, but for some reason it couldn't be used to create networks. Now I think it can. So you don't need this for newer ones, but let's just do it. Let's just go through this example the way it is, and then someday I may update you all with more up-to-date information with the Docker 1.12 stuff. So we do need a key store though. So the key store can be based on a lot of different technologies. It can be based on Zookeeper. It can be based on console. This is what we're doing here, console. There's a couple of others. We're going to use a console key store, and we're going to create its own virtual machine with a single container running on it for the key store, and that's these 3 commands. And that thing that says val should be eval. Sorry about that.
It should take a while, the first command?
Yes. Yeah, it'll take a little while.
Yeah.
Now I have these all.
Got an error validating certificates for host.
All right, so that's going to be one of those things that happens in Docker occasionally, Docker machine occasionally. If you recreate your keys, you're going to end up losing connection to your VirtualBox. So, to the other things in the host. Usually, you can just do a regenerate keys if you're just using a single machine, but in a swarm, the keys have to be compatible. So, your best bet is to delete the machine that it created and do it again.
Okay. So I'm going to stop the key store. And then you said to delete it as well?
Yeah, the Docker machine RN.
Works fine. We can go on to the next managing node bit.
Yeah, so we're going to create a managing node. Feel free not to create the second agent node. I mean, you'll get the flavor for it even if we just have one agent node. The idea is that you can scale this to as many machines as you want, but scaling them by putting extra virtual machines on the Mac is just not, doesn't perform very well.
Yes.
But we should still create the managing node, right?
Create the managing node and one of the agent nodes, yeah. at
Okay.
least. And you can create both agent nodes if you want.
And they're managing the nodes on a network, right? That's what it means.
Right, so that's the kind of the main scheduler, right? That's running, and I think in Docker Swarm you can have multiple manager nodes. So you can have some redundancy in the scheduler as well. So if one of the nodes goes out, you still have a scheduler that's been sharing information with it.
Yeah, same thing. Error validating certificate for host.
What version of Docker are you running?
How do I tell?
You can do Docker dash version.
1.11.2.
Okay, that seems reasonable.
Try it one more time.
Yeah.
Freaking so hard, right?
Keep in mind also that your target environment is never going to be a Mac. These are usually used for developing, but we're not racking these things out in the field and running our servers and services on them. This is all targeted at Linux machines, really. So what we're doing here, we wouldn't normally be doing, except unless we were trying to test something to do this run locally. But even then, it's probably easier just to throw up some boxes and throw up some VMs in your cloud provider and run them that way. I think what I would do on since it's your first one, Sean, and it's still having a problem, I would try recreating the key on that, recreating the certificates on that one, and then
You mean with the Docker machine create command?
The Docker machine, after you get done with create one, if you're still having that same problem, then you would want to run, there's a recreate cert command. I don't remember what it is.
Okay.
Are you still having the same problem?
I don't know yet.
Not that.
Just making sure I've got it.
I know.
You have a problem?
It's good. It's good.
So it's working,
To work fine.
setting up VirtualBox, no problem, huh? That's cool.
I mean, I think I have VirtualBox on there already.
You don't want to do it.
I need it.
So notice it's pulling everything down again when you do this. And that's because every Docker machine has its own image cache. So sorry about that. I completely rewrote these instructions today because they were using different.
So it just worked the third try without any changes.
It's the update.
So apparently if you just keep doing it,
And it would be nice to know what was actually happening. I probably won't investigate it today.
so the key is to keep doing the same thing and expect a different result.
That's right. Welcome to Docker.
It's not definitive.
It'll work.
Second one, man.
It's the elevated.
All we need to. I'm not sure, but I hope.
That I always do. That's why you started with the time. And really, you should program your your containers defensively, so that if you depend on a database, that they shouldn't crash just because the database isn't there. That's how the idea is to have these things fairly loosely coupled. So they should behave in some non-crashy way, or at least some replaceable way when you think of the resources you need. Because if you don't, then you end up, especially with a microservice architecture, you end up with requests coming in still, and you're just crashing and wrecking those things instead of rejecting things, saying, I can't do this, I can't do this yet. And those requests just keep building up, and build up because the clients keep trying, and you're trying to end up actually multiplying the network problems if you do what this application doesn't crash.
The computer's working hard.
Mm-hmm.
There are a lot of things going on.
Yeah, mine's like really.
We're warming up the room.
It's going with the
So if you get into, because the one thing about the last document, that one document where it says the valve Docker machine introduce swarm manager, that swarm flag tells it not to attach to the manager machine as if it's part of the Docker stuff on it. You're going to actually choose a different port. There's a hidden container running in there that is accepting the commands and behaving as if it's one Docker machine, even though it's multiple.
So I'm getting error attempting heartbeat call to plugin server, an error creating machine, error in driver during machine creation. I'm getting a lot of errors.
You are getting over there.
On that Docker machine IP name, what is the name that you're doing it? Because the name that I'm getting is Docker PS and not something else. I'm supposed to run it.
You do Docker machine in the swarm manager.
Yes.
And then you do Docker PS in there, what happens? Or Docker input, what happens?
A very large container 9 running 7 5 11. Looks happy.
And then you do Docker troubleshooting and go with it.
The Docker machine IP name. After. Yeah, I'm not sure if I'm going to. I assume it was
Oh,
Docker
so you do Docker machine LS.
Oh, okay. I'll probably not be able to do that.
You know what manager. Sorry, that's that command right here that I can't do the manager. So you can just connect the manager, eval Docker machine into swarm manager.
When you say get some information with Docker info, that's a little vague, isn't it?
I just want you to see that you can.
Okay, all right. It's not information that we're going to need for the next step or anything.
No, the main thing is just to show that things are up and running.
Okay.
Site copy.
And this is a different page of information than you would get if you just attached to a single Docker machine. You'd get a lot less information. This is telling you about the Docker.
I'm getting the site copy.
Oh, right. So you don't want manager as the IP address. Let me tell you. You're going too far out. Hang on. See everybody running. Everybody should tell me when they've gotten to the point where they run Docker compose up -d. All those steps. So Docker compose build should work. So did you remove that machine and try again, Sean?
Yeah, my machine froze for a while. It just came back, so I'm about to try it again.
Wow.
How do you remove the machine, Docker machine, RM machine?
Docker machine RM in the name of the machine. Yes. It has to be stopped. I think. So yeah, we're doing a use case that's really not. This is really purely the innovation. So this is not something you would do. This is just to show you what might be happening. Might be happening if you're doing this in a cluster up.
Right.
So if you can't get through this, we can just share screen. This is not. We would never be doing this in anything.
So once we get up-d running, we'll almost Yep.
You can see with all the solid aluminum decompression is pretty over-engineered. You use it like this.
Okay, second time seemed to work.
That makes sense.
Creating the agent nodes.
With the instrument, I would definitely advise against making a second agent.
Okay. I'll just make one then.
Great. I noticed that you can't call Docker machine ID on one of the agent nodes. And looking at the commands, it looks like the only difference is when you add in the keyword swarm. I guess the only difference between the two keywords is one has swarm master and the other one doesn't.
Right.
So when you do swarm master, I guess it registers itself as, okay, I'm the main, person that's going to communicate with the rest of the agent
Right.
nodes.
Right.
So that's why you can't query for the agent's IP, right?
But you can query it without this form. So
Okay.
once we get a listing, then we can see. That's what we'll go through during the site.
Okay. Cool.
If after running Docker compose up -d, you run Docker ps and only see the Redis container, just run it one more time. It just means it failed to get. It was just a timing issue. And if you look at my screen, you can see it's distributing, putting Nginx, performing Nginx in both places.
Okay, got an agent node up.
And that's from the back.
I got some Docker info.
It's a lot of info, isn't it?
And that concludes that. Yeah. You get your option.
You say we're gonna run over break. Let's take it until 4:30.
Oh, then I guess we're not. Anticipated. That's why I
You have time yourself.
Nice, you anticipated yourself, so you set a contingency for
I
that.
had a feeling there would be like a problem.
I also did notice that when you run Docker PS after you run the Docker build and Docker compose up, that all the names seem to bind to the manager. Like you'll see manager / cart to store and all that other stuff.
Right. But inside the containers, what's interesting is that they still have the original simple names.
Okay.
So that's why this still works. And that's what these overlay networks do, is they create virtual networks between all of their hosts, and they allow us to use the same names. Now, this is not the same as a discovery service. Like if I wanted to scale out my services, I'd still have to have a way to tell Nginx that I'm adding new nodes, new backends. And there are things to do. We'll talk about this in a second before we're done. But scalably running the app on multiple hosts.
And I guess what I was trying to say was it looks like it kind of is, it assigned the name at, like a space like manager /
whatever the name of that container is. But like you said, you can still run the container given its same
Right.
image name. Yeah. Okay. Cool.
So what's the significance of the red coloring versus the green coloring? Are they different types of output streams?
That's an NPM thing.
Okay.
So NPM install adds color to the output. I don't know what it means.
Yeah.
That's Node.js. Frankly,
So it's not Docker doing that, that's just inheriting it.
yeah. I find that the output from NPM when I'm building is really shabby. I can't find it on my still because it's so much information.
It's a common complaint with NPM. They also vow to always be backwards compatible, so they can't actually remove some of that output because people might be depending on it. So it seems to only grow. Someday they'll break that and they'll clean it up. But interesting. I actually don't see any green. I only see red. So, the info is orange, a lot of red. So.
Well, yeah, everything from NPM is red, but stuff like from Redis and Express seems to be green for me. Oh. Got a lot of green.
It is a lot of green.
Red.
It's still waiting.
So I just got the Docker Compose working. I'm doing. I gotta get the name of the load balancer.
So let's do a Docker PS and make sure everybody has all the containers running because if not for the second time, you should have four
I got 4.
containers running. And you notice the one that is called Nginx here, the one that contains Nginx, and it's actually called port 2B balancer 1. There is an IP address attached to it. That's one way to get it right there. And that's the IP address of the load balancer. Now we could have actually told in our compose, we could have actually given it a hint that we wanted it to always come up on a particular box or whatever we want. That's totally doable in the scheduler. I didn't this time just because it's fun to try. But that's your application's address. So if you go to your browser and type that address in, you should get your application again, but now it's running across multiple machines.
You don't even need to do that. You just say, just connect to Docker PS. Because the Docker PS will show you.
Yeah, that's a shortcut. I just
Grab
grabbed
that
that.
IP, it's that in the browser. Yeah, otherwise you have to put the Docker machine IP and then rebalance it.
This is the Nginx from that was targeting Crystal.
What is?
Is this the Nginx container from?
No, that was in your default machine which we stopped.
Oh. I deleted it.
So if you look here, so we did Docker PS, we got all those 4 things up, we got the IP address. Now if you look at what this is doing, this is 104 running my app right here. And if you look at the container configuration, you can see that these are actually running on different boxes. So actually mine are all on different. Oh, because we didn't put up an okay, so one of the good reasons to put an agent B is so that the load is actually distributed across multiple machines. I actually thought when I did this before it did some of them on Manager, but it apparently didn't, at least on my machine this time.
So when it says Docker machine IP name, what exactly is that name?
Sending your Docker machine.
That's the name.
So in our case, it would be Docker. So it would be manager for our Swarm manager, and then for the key store, it would be key store.
So we want the IP address of Swarm.
You all don't need to
So
do
yeah,
this.
so,
I'm
so
doing
that's
this
yeah.
example.
So manager is the IP address of the Swarm.
So if I go to 10, so I went to 103. If I go to 102,
I'm gonna bring
102 is not a
on mine, I'm
thing.
going to bring up an agent B, and then bring up the application again.
Because 103 worked,
Feel
but
free to
that's
do it
because
if
it's
you're
Engine
feeling
X.
adventurous.
Okay. Oh, John. If also if you take a look at your processes, it looks like the load balancer is mapped to this port right here.
Right, well that's how I found the 103 one,
okay.
which that works.
Mhm.
So that's where Engine X is.
Mhm.
But this IP, the Docker machine manager, gives me 102.
Mm-hmm.
So why did we get that? Is what I don't understand. Why did you need to do this command here?
Which one?
The Docker machine IP and then the name?
Right. So what I was just saying is that you don't need to do that. You can get it from
Yeah.
Dr. PS.
Right.
Yeah, that's what.
Well, it seems to give me the wrong number anyways.
If you use if it has dash swarm, it will probably be the wrong one. That's a mistake.
Yeah, I was going to say that looks like a mistake because if you read the prompt, it says to get the IP address of the load balancer, and since you get that from Docker PS,
Right.
So I now have. I'm going to bring it back up now. I'm going to bring this back up with with two machines running. So I now have Docker using Docker machine. I have now a manager, and agent A and agent B all running. Now I'm going to launch the application. Okay, now you can see that they're again all running on agent. Why? All right. Well, I can tell you that earlier today I had them running on multiple units. I do not know why. So this is one of the things you kind of are relinquishing control to a scheduler, saying, scheduler, go make your best effort to distribute these in whatever your algorithm is. In this case, it chose. No idea why it chose to only do it on agent A. Let me do a Docker. Because there should be three CPUs, but for some reason it's putting them all on the same one. Don't know why. All right, that's a research for another day. But in general, the idea is that when we launch this thing on multiple virtual machines out there, that the scheduler decides to put the containers, and they actually will communicate across the containers as if they're all on the same machine. And sorry that didn't. None of you are getting separate machines, right? When you do a Docker PS, like between agent A and manager. Because I thought
I only started up one agent.
I thought I saw them on manager as well before when I was doing it.
We shouldn't, or we shooting in separate machines?
Manager slash.
You have some on manager?
Yeah, two manager and two agent A. So I stop it and start it again. I get the same result.
Okay, so
I have manager and 3 on agent A.
okay, so it's just my machine. So the Swarm scheduler decided on mine that agent A was the right place to put all those containers.
All agent B.
But on some others it's distributing them, including manager, which is what I thought it had done for me before earlier today. So that's it. That's the idea of a scheduler and the idea of scheduling collaborating containers. Let's go back to the last part of this thing. And I just had some final thoughts. What was I wanting to talk about? Oh yeah. So I already mentioned that doing things like load balancing or hitting a single database and that kind of stuff requires more complex kind of configurations where you need more control over what's happening as containers coming down. You can get very complicated very quickly, but my advice on all this is to keep it as simple as possible until you absolutely need the complexity. Because just allow yourself to give up some control and let the tools do their job until you find a reason why you have to have some affinity between a box and a container, or you have to, or you need these two things to run on the same machine. Until you can show that you need those, just let the schedulers work. There's a project here I mentioned called Interlock that is used to control both Nginx and either Nginx or HA proxy load balancers. As containers come and go, it'll reconfigure those to load balance across them. There are other projects along those lines for many other scheduling duties and problem solving. So if you have a particular problem and you're trying to deploy an application across multiple machines, look to the projects out there, because there are quite a few projects, people exploring this space and figuring out what's going on. And then finally, aside from the bugs we saw here, which I'll try to remember and fix, if you have anything you want to change, you think this presentation needs different, just I'll look for your PR and I'll try to make this thing better. So, any questions or things we want to talk about? Everybody feel like they're recognize the world?
Not quite.
Or at least compose the world. Not quite swarm it yet. Because I've had some experience using compose, so that I was more or less familiar with. The swarm, on the other hand, is especially all the network configuration and so on. It's like, okay, that's going to take me some time to, or at least a sample project, just to wrap my head around.
Right.
Because there's a lot of information with the swarm that's going on that definitely could be explored in greater detail.
And Swarm, I think, is probably a pretty vanilla scheduler. There's probably a lot more features if you get something like Kubernetes. You need them. Because it's been around. It needs to have it's been solving, I think, more problems around it. But I think I'm going to explore the 112 a little bit, because with 112, there's been quite a few changes to the way continuing collaboration. So I'm going to explore that and see, and kind of visit Swarm as a possible production station. And if not, then right now we're installing using ECS. I think Ad Systems has been working with Kubernetes. So maybe we'll go further and see. Those are the
So I was using 112 the whole time. So it seems like it's right there.
Are you using the 112 like toolbox or the 112 like micro? Like the one you saw.
That seems more information than I was Docker for now. When I do Docker dash approve and
Did you install it through Brew, or did you install it through Brew? So you got the Michael did. You did the DMZ.
Yeah.
That's new, but that's
I've got a little-
less than the-
I've got a little thing up in my toolbar in the top. Docker, wait on it.
I have a Docker wheel.
Saying that's, if you have that.
Okay. Thanks, everybody.
Thank you.
Hopefully it's recorded, because we have 2 people recording it.
Meta.